Welcome. You will understand what GAMS is, the building blocks of every model, and how to read or write a basic optimization program. By the end, you will know the core ideas, sets, data, variables, and equations. So, what is GAMS? GAMS stands for General Algebraic Modeling System. We need to think of it as a translator. You write your problem in simple math language, and GAMS sends it to powerful solver that find the best answer. Its job is simple. Take a real-world problem like production planning or logistics or scheduling and translate it into math. We need to define three things. The first are the choices. What decision can we make? These are the variables. Rules or limits. What restriction do we have? And these are called constraints. Then we have the objective. So what we want to achieve. And usually we have maximization of profit, minimization of cost, or use a resource efficiently. So GAMS is just the language that lets us describe these three pieces and then a solver find the best solution for us. When we define the terms optimization, we define it as choosing the best option among many possibilities while respecting all the limits. So we need to think of it like shopping. You have 20 euro, apples cost 2 euros and give 3 points of wealth. Chocolates cost 4 euro and gives 5 points of happiness. Your constraints, you cannot spend more than 20 euro and you cannot buy negative items. Your objective is to maximize total points. That's optimization in daily life. And GAMS does the same thing, but with larger, more complex problems like factories, supply chains, or energy systems. In optimization, the objective of a model is always one of two things. First, maximization of profit or minimization of cost. We usually call this objective variable zeta. So, whenever you see zeta in a model, think this is the final score, the value we are trying to optimize. Every GAMS program is saved as a text file with extension .gms. So, when you save a file, you will find usually the extension GMS. Tabs at the top allow you to have multiple models open at the same time, like you can see right here. A GAMS program is written in blocks, always following the same logical order. So is always written following the same blocks that are sets, parameters, table, scalar, and these are the input data. Then we have variables, and we define the typology of variables that we have, equations, and then the last part where we define what kind of model we are going to solve. So the structure is always the same. We need to remember that after every block, we need to write the semicolon structure. Without this, the system will produce an error. Before diving into the core functions, I wanted to underline one important point about comments. Comments are these writings like here that the program doesn't read but are essentially and important for the users because allow him to remember what's going on and make notes about what he is doing in the program. To write these comments, the user can use two kinds of system. The first is using $symbol on text, write the comments in the middle, and then finish the comments with the off text. So between on text and off text, there is all these writings that represent the comment that the program will not read. Another system that is the simplest one is to write a star symbol with the symbol and write the comment only using one line, because when you go at a new paragraph will not be a new comment but a new line of code. So from that point on, you will write something that the program will read. So when you use the star, make sure that you write something short. Instead, if you want to write something longer, you can use the other method. This is pretty much the basic of what you need to know about notes and about comments. There are other methods, but in this video we will focus on that. Every GAMS model follows the same 6 steps as we've seen: sets, data, variables, equation, model and solve, and display. Starting from the first, the sets. Sets are just a list of items. For example, if you have two products, we define the products with a capital letter E and we define them as A, B, C. These are the values of the kind of products that we have. Another set of elements can be the time. So in this case, we have the months. Here is the comment that is associated with the index. And months and the values of these months are E for 7. This means that every months from 1 to 7 are involved in the program. So in this case, means that from 1 to 7 months are involved. Index are labels, as we can see like here, like that or like that represent each element of a set. It's like a shortcut to apply the same rule to many items at once. So you don't write one equation per product, but one equation with index E that covers them all. Typical index in the industrial problems are E for product, items, or suppliers, J for destinations, customers or machines, and T for time period. Remember, you can name any index as you wish, but E, J, and T are the common worldwide convention. They make models easy to read and recognize across industries. Allies, as we can see right here, are useful when you need to use the same set twice. Example, we have cities. You want to model travel from one city to another, and so you need to have an access of each element of the set and not to use the whole set together. And so you need to take in consideration the set that you want, in this case product. And if we wanted to access the elements of the other product, we will have E and J as another letter to indicate, for example, or B or C. So this allows to reference the single element inside a set. Another part that we need to cover that is essential to understand the core of these problems are the typology of data. When you read a problem in optimization, you need to first capture every input data. And the data can be, as we can see, we have already seen sets, but there are 3 typologies of data. And these data are parameters. Parameters are numbers linked to sets. So we have values associated with one particular set. In this case, we have profit and interest. Profit that is associated with the set E. And so we will write an index E, and interest that is associated with T. So we will write the index T. These 2 parameters, every value associated with either E or T according to the set that they represent. So profit E is the profit for each product, and interest T is the interest that is maturated every month. Then another typology of problem are the tables. Tables looks like a small spreadsheets with rows and columns and represent a correlation of data between the 2 sets. In this case, the correlation is sales, E and T. Here we have a table with binary variables, binary either 0 or 1, according if at month T we have sold the product E. If we have sold it, then we can write E. If we have not sold it, then the value is 0. So, for example, at month 1, the product A was not sold, and so we write 0. The last one, the last typology of data is the scalar data. Here we have hours, 40, means that these numbers, the number of total hours, is a fixed value that doesn't change across the program. And this is pretty much everything you need to know about the typology of data. Once you determine the input data given by the text, then you need to ask yourself a questions to understand what do we need to find, and these are the unknowns. The numbers the solver will decide for you. The most common variables that are used are X, that represent how many units to produce, ship, or use, so represent a continuous number, a quantity. Y represent usually a yes, no choice, so a binary, 0 or 1. And zeta is usually the objective function that represent either the maximization of profit or the minimization of cost. And in GAMS, they are written like this. So positive variables, you indicate specifically the positive variables. In this case, we have X associated with E. So also when we write variables, we need to associate the variables with the right index. Apart from zeta, that is the objective function that does not represent any index. Binary variables, epsilon e, this is a yes-no type of decisions that we will go deep on in the next exercise. Integer variables kappa. Every variable is linked with a particular set of reference. And these are the type of variables. You can choose the name of the variables, but these are the ones that mainly are chosen for every optimization problems. As a general review, we have 4 type of variables. We have the free, we have the positive, we have the integer, and we have the binary. Each one used for particular conditions and used in particular cases. Now, as I repeat myself, the scope of this video is not to show you every single use of these variables, but simply to show you what kind of variables we have and what they are. So this is a remark that we already done. Bounds are attributes of the variable. We have 4 types of attributes. So we have the level. Level is the solution value chosen by the solver. So for example, once the solver solved for x point L equals 50 means that the solver decided to produce 50 units. Point low, lower bound, is the minimum allowed value. Example, x.low equals 0 means that the production cannot go below 0. Point up, so the upper bound, the maximum allowed value. Example, x point up 100 means you cannot produce more than 100 units. Point M tells you how much the objective will change if you relax or tighten a constraint by 1 unit. This is useful for sensitivity analysis. And then we will go to the one of the most important part, that are the equation part. Equations describe the rules or constraints. In GAMS, we write them with logical operators. E equal, L less or equal, and J greater or equal. So usually the main and common equation or constraints that we have are the objective function. So here we are calculating the quantity that we are going to produce for the profit. The capacity here is the capacity XC per PT. In this case is the production time for every quantity. And the link is a binary condition where the capacity is, it must be respected only if the line or the quantity is produced or not. So this is an example that does not refer to the previous data. The most important function that you can use in GAMS is the sum function. What it does, it adds values over a set or several sets. And to write it, we need to use the function sum with the index plus the expression that we want to sum. Which this means that for every element in the set defined by index, we calculate the expression and add them up. In this case, we have in the objective sum for every index E, so for every product, the quantity of the product E per the profit E. In this case, we are going to find the total profit that we need to maximize. This is a brief example considering one with only one index. So in this case we have a set E composed by table and chair, and the equation is sum E profit E. Instead, in example 2, we have two sets with products, warehouses. And so, to do the sum, we need to consider the two indexes, and we sum the total cost across the two parameters and the two set that we are going to consider as whole cost across products and warehouse. So, sum is a compact way to write add this for every element of a set. When your stats, data, and variables and equation are ready, you join them into a model. So model, my model, composed by all. Then solve my model, so the name of the model, using LP, maximize zeta. You can choose LP and MIP according to the kind of variables that you have. LP is used when you only have continuous variables or quantity variables. But when you have also binary variables, you don't use LP, but you use MIP, mixed integer programming. So you will solve this model using mixed integer programming. And when you use MIP, you need to add these two integrations that make sure the model runs efficiently without any problems. So you put the name of your model, point OPTCR equals to 0, and model point OPTCR that equals to 0. You solve the model using LP or MIP according to the variables, maximizing or minimizing zeta according to your objective. And then the last part, to see the final results, you put the variable that you want to find, in this case x and profit, point L. L is leaving, indicate that that value was already solved and you want to see the final solution is the value that was solved by the program. And that is everything that we need to know about this case. As a final project, to really understand deeply what's going on in simple steps, I prepare for you a brief example, short example, where a factory makes two products, tables and chair. Each table gives a profit of 50, each chair gives a profit of 30. Each table needs 5 machine hours and each chair needs 3 machine hours. The factory has 150 machine hours available per week. The manager wants to decide how many tables and chairs to produce in order to maximize profit. So here the objective, and there are a series of constraints. The first step that we need to consider is to define the input variables. In this case, sets with E, considering table and chair, so the values inside the part or inside the slash are table and chair. Data, we have a parameter. In this case, we have a profit that refers to the set that is always the same because we have only one set, and time E that refers to the other kind of time that refers to machine hours. Then we have scalar hours available, so the total hours available are 150. This is a value that doesn't change. Then we need to define the variables. Once we define the variables, we have xe, that is a positive variable, is the quantity to produce. And the variable zeta instead is the total profit. As equations, we have the maximization of the profit. So in this case, we have zeta that equals to the sum for every product of the quantity produced for the profit, and hours, the sum of for every E, the time for xe, the total must be less than hours available, that is the maximum cap. Then, because we have only continuous variables and we don't have integer variables or binary variables, we write solve model, production all, solve prod using LP maximize zeta, and we display the information with x.l and zeta.l. That's it. So this is about the example that you needed to understand what we're build. Learn this and you can build any optimization model. In the next video, I will show you how to use them to solve a real case in 10 minutes, starting from a production problem that are the most common that you can find in any optimization university course. Thanks for watching and bye.